So as I mentioned, the authors have updated this textbook, handbook is what they call it, with the 8th edition, and they've included a few pages on LED lighting, and which is very good. It's very up to date. Uh, that they should finally do that. I would expect that in future editions of this book, they will remove some of the older data that's in there and have even more information on the LED lighting. Right now, we're waiting for LED lighting to become more standardized, and once that happens, we'll be able to find more charts like we found in this book, comparing different uh, lighting examples and offerings from one manufacturer to another. For example, you can buy 32 watt or 34 watt or 40 watt fluorescent light tubes from a variety of manufacturers, and they'll plug right in. Well, we're not quite there yet with LEDs, but what we are seeing is a vast number of manufacturing companies that are bringing LED lighting into the country. We're going to see that continue to decrease, those costs, and when that happens, we'll see more and more installations go up. So let's talk a little bit now about what is the new edition that's in the book. So I've taken some photographs with my cell phone of the new pages, and I've just plopped them in here nice and easy. And so I will go over those pages with you now. Forgive my horrible photography skills, but I think you'll get the idea. So they're talking about, on this page, they're talking about the different styles or terms used with LED lighting. And I don't think that's a significant thing to get wrapped around the axle around so far. Something will come to the lead as far as manufacturing, and most other manufacturers will follow suit with what gets produced and sold. So one of the things that we have to be able to do, or a couple of the challenges, we're coming up with lighting colors. The early LEDs were just plain difficult to live with. And so the real challenges to the manufacturers have been to come up with color varieties so that we can meet the color rendering and indexes and so forth that we've talked about earlier. The styles of the lamps, here are some examples of what you can find. These are the styles that would screw into a regular light bulb outlet, as are these over here. This is a candelabra, and here we have the type that would plug into what would be known as a halogen fixture. Here we have some desk lamps, and this would be like an under cabinet lamp. One of the things I want to point out here, though, is that, excuse me, that much of the engineering that goes into these are to find ways to dissipate the heat that's created by the electronics required to run these things on the DC voltage that they need. This is known as a heat sink. There will be more of these on future pages. LEDs are known as directional light sources. So they only emit light in a specific direction. And so if we're wanting to light a room similar to the way we would do with a compact fluorescent or an incandescent light that we saw earlier in the chapter, then they have to come up with different reflectors and diffusers in order to get that. So that's been a bit of a challenge as well. One thing about the LEDs is that they don't burn out in the same way that a light bulb burns out, an incandescent, when it's either working or it isn't. And it's normally a very, very short period of time where it gives you a reduced amount of light. It just fails. With an LED, what happens is the amount of lumens that are created are directly proportional to the number of actual light-emitting diodes that there are. We create more lumens not by putting in a bigger diode, but by putting in more of them. And so what you'll find in some of these is that as they begin to fail over time, that maybe of the 100 LEDs that made up the bulb, you'll start seeing several of them to burn out. And when we get down here, it's listing here as once we get below the light output is reduced by 30%, then we won't be having the efficiency or the lighting efficacy that we were looking for. So, and again, that brings me back to the heat. One of the ways these things are going to destroy themselves is by having by getting too warm, by not dissipating the heat. And so we're going to do this by using the large heat sinks that I explained on the previous page. So how do LEDs lighting difference, how are they different from other light emitting technologies? Well, they've had to add some electronics to it in order to get the colors, in order to get dimming capabilities. By now, many of you have probably seen that you can get some very sophisticated controllers with these, and the prices are coming down significantly. LEDs are certainly more efficient than incandescent light bulbs, and more efficient than most compact fluorescents. There are some compact fluorescents that do have very good efficiency, but I think we're going to see those go away. So, and by that I mean they'll be surpassed by the increased engineering. So we see here on this page where the Department of Energy has long-term and research and development goals that they fund through grants and so forth. And so what they're hoping for is in another 10 years or so that we will get 25 lumens per watt, 225 lumens per watt of electricity being used. That is significant. Currently, though, the chart that's shown here shows what we can get out of these particular lamps. And so they're showing the top 4 are LEDs, right? And then we're going to get to the high intensity discharge, the HID systems that we find in many of our factories and commercial areas. And then finally the linear fluorescent system. So these are the ones that we're seeing in most of our buildings right now with the fluorescent tubes. So we've got to challenge that. And look, we're starting to do that. So these troffers, these 2 foot by 4 foot troffers, 131 is their efficacy. And remember, that's lumens per watt. So that's better than our standard light tubes. Compact fluorescence, you can see, is a little bit lower. Halogens are significantly lower, and incandescents even lower yet. So this is a nice chart to help us out. Cree is a large manufacturer that has been a leader in industrial lighting for many years. And there, I looked up this particular light bulb that's shown here, the ZR High Efficiency LED troffer. I looked this up, and they compared it to the T8 fluorescent troffers, which Cree also makes. So now notice they're listing here that these have a 150 lumens per watt efficacy and a 10-year warranty. Well, I didn't find that when I looked online. Maybe you will. Again, I talked about the color, and these are some of the areas that we are going to find that are going to be the slowest to be developed. You can get LED lighting that is warmer, but you will pay a premium for it. If you look online to something like eBay, you will find you can get some really inexpensive light tubes that'll screw or install right into a standard fluorescent fixture that operate very well in the 6,000 color scale. But that's pretty darn bluish, and that may not be so bad for your garage or a shop area, but it wouldn't be good for an office or many commercial sales areas. The color rendering index is the same as we had seen before, and we're using a scale of 0 to 100 is what we would looked at before, and so that is continued on here. One of the real benefits of LEDs is their longevity. They last significantly longer than even CFLs. We can see the comparison here, 30 to 50,000 hours as compared to an incandescent, which might last 1,000 hours, or a CFL, which is 8,000 to 10,000. Many of you have seen the display that we have shown our students. You guys have actually helped display these things, and we have the comparisons that show how much longer these things last. So we've experienced that as well. Cost effective. I thought this was a really interesting paragraph. It talks here about trying to bring the price down, and they have come down. But notice, again, the Department of Energy is hoping to try and get prices down to $2 per 1,000 lumens by 2015. Well, this is 2016. They didn't make it. Not even close. All right. So, but it's still a good goal, and I think we will see it come down. Again, because there's a lot of money to be made. LEDs are really, really cheap to manufacture, and the more people get involved in manufacturing, the more competition there will be, and the prices will get better. Now, I would like to mention that I did look at that Cree example that was shown there, and then I compared that to some non-brand names that were available on eBay, and the eBay prices were significantly lower than those that you would find from the name brands like Cree and Sylvania and so forth. So you can get them significantly cheaper, and again, that to me is very encouraging that we will have lower prices of LEDs. Not that I just want to spend less money, but that I want to see companies and people invest in this type of technology so that we can reduce the amount of energy that we're using. There's a couple of examples here in the book. One of them here is example 6-7, and it's mentioning that we've got a school that has 100 2-lamp 32-watt T8 troffers, and each of these have 32-watt lamps, and so that's 2 of them, right? So 32 and 32 is 64, right? And then it also states that we're going to be replacing these with 22-watt LEDs. The LEDs are direct replacements. So this is where I kind of question this this example here, because well, actually this should work out just fine. So we're going to replace all 200 of these lamps, right? There's 100 troffers, each has 2 lamps. We'll replace each of those 2 lamps with 2 LEDs. And so if we look at the math down here, we're going to see that the 200 lamps multiplied times the difference between the 32-watt fluorescent tubes and the 22-watt LEDs, multiplied times the 8,000 hours, the 4,000 hours per year, results in a total of 8,000 kilowatt hours per year. When we multiply that times the 15 cents per kilowatt hour, that comes out to be $1,200 a year. Now, we got to buy the new lamps. They're $19 a piece. $19 a piece times 200 is $3,800 bucks. When we divide that, the $3,800 cost by the $1,200 annual savings, we're going to see that the payback is right near 3.7 years. However, remember, these lamps last twice as long, so it's going to be way less than 3 years. One of the things that was not considered in here was the cost of replacements. By that I mean the labor involved in doing that work. What I don't know is if they would all need to be installed at once, or could we buy the new LEDs and have them sitting on the shelf, or would we just wait and we do our group relamping strategy? There's a bunch of ways to look at this. But I think we can see the math is pretty obvious. The LEDs are a winner over the fluorescents. The second example here, again, we're just looking at how to save money. We're not looking at anything specific about lamps. So here's our example. We're presently lit with 28 2 T12 34-watt fluorescent lamp fixtures. So that's 39 watts per lamp, including the ballast. What are the annual savings of replacing the existing lighting system with a single 18 LED with 18 single LED luminaries, which each have 44 watts per fixture? We're going to use 6,000 hours of operation, 12 cents per kilowatt hour, and a demand charge of $8.50 per kilowatt each month. So they're showing here that the delta, the change in kilowatts, would be, so if I had 28 fixtures that are currently using, look what they're doing here. They're converting right away to kilowatts instead of doing from watts to kilowatts. So this is kind of nice. It'll take one less thing out, right? So 39 watts is 0.039 kilowatts. We multiply that times the 28 times the 2 fixtures, and we will subtract from that the 18 fixtures, which each use 44 watts. And by doing the math, we come up with 1,392 kilowatts, right? So that's instantaneous, right? That's instantaneous, and we can multiply that times the demand of $8.50 per month times the 12 months a year, and we're saving almost $142 just in demand. Not that much really, but maybe. So let's take a look now at the energy savings. If I multiply the amount of energy times the amount of demand, that 1.392 times the 6,000 hours per year times the 12 cents per kilowatt hour, now we're saving another $1,002. So $1,144 a year is what we're saving. And I think it's kind of obvious that we would then need to compare that to the cost of installation and do the rest of the calculations like we did the value of money over time. So LEDs, they're going to work out pretty well. I want to show you one more thing before we go here, though. I want to show you some of the things that we may need to consider when we're looking at installation. So I've got a chart here that shows, whoops, already there. I have a chart here. This is a T8 installation guide, right? So remember, the T8s, that's a 1-inch tube. So they make LEDs that are direct replacements for the LEDs. Now this is the instructions that come with it. Now notice that this can be plugged right in. We want to disconnect the power before we do it. And it's rated, it can handle, the LED can handle anywhere from 120 to 277 volts. So that's pretty good. So that means it's available for worldwide use. So note there's some information in here that is pretty important. To avoid potential fire or shock hazard, do not use this retrofit kit in luminaries employing a shunted bi-pin lamp holders. Note, shunted lamp holders are found only in fluorescent luminaries that have what are called instant start ballasts. Instant start ballasts can be identified by the word IS, by the initials IS or instant start. All right, and so we can determine if they have these with a multimeter, and they have an example here, right? So this is non-shunted. There's no shunt down here on this end. Notice, see the shunt? That's a short, okay? So we can't use them in these, so we need to find this out. This is an example of some of the things that you have to look at. This is an example of why we may need to do maintenance. So here's the installation steps. Shut it off, remove the ballast, and once the ballast is removed, we are going to then connect line 1 and line 2, or in this case neutral, because we're doing 120, just to one end. The other end isn't really, there's no electrical connection there. That's just literally meant to hold up the other end of the light tube. So it looks like a standard LED, or it looks like a standard fluorescent light tube, however it's not. It's just got LEDs in there. So do some looking on the internet, you'll see it. Now here is a multiple tube style. Again, get rid of the ballasts, and they're showing how we're just going to jump hot to hot to hot, and there we go. Pretty simple stuff. And but maintenance technician's going to have to be paid to do this work, and so that needs to be considered.